we're going to evaluate the integral of x times inverse tangent of square root of x dx. First we'll make a substitution. Let y be square root of x, then y squared is equal to x, and dx is equal to 2y dy. Let's rewrite the integral by changing variables from x to y. X is y squared times inverse tangent of square root of x, which is now y, times dx, which is 2y dy. And this is the integral of 2y cubed times inverse tangent of y dy. We'll evaluate this integral by using the technique of integration called integration by parts. So the integration by parts formula is the integral of u dv equals u times v minus the integral of v du. Let's make a choice for u. Let u be inverse tangent of y and dv 2y to the third dy. Differentiating inverse tangent of y gives us du equals 1 divided by 1 plus y squared dy. And for v, normally we would take 1/2 y to the fourth because the derivative of 1/2 y to the fourth is 2y cubed, but we can also add or subtract any constant that we want, and in this case subtracting 1/2 would be advantageous, and the reason is this is equal to 1/2 times y to the fourth minus 1, or 1/2 times y squared plus 1 times y squared minus 1. The integral on the right in integration by parts formula is the integral of v du. So you can see when we multiply v by du, du has 1 plus y squared in the denominator, and this selection of v with subtracting 1/2 gives us y squared plus 1 in the numerator, and that will make that second integral easy to evaluate. So now let's go back to the integral. We have integral of 2y cubed times inverse tangent of y dy. It is equal to v times u, so that's 1/2 y to the fourth minus 1 times inverse tangent of y minus the integral of v du, and that integral is 1/2, and then integral of y squared plus 1 times y squared minus 1 divided by y squared plus 1 dy. You can see that y squares plus 1 cancel, and the integral that we have left, let's do that right over here, is 1/2 times the integral of y squared minus 1 dy, which is 1/2 times 1 over 3y cubed minus y, and that's 1 over 6 y cubed minus 1/2 times y. Let's again return to the integral. Our integral of 2y cubed times inverse tangent of y dy is equal to 1/2 y to the fourth minus 1 times inverse tangent of y, and then minus the second integral which we just computed, and that is 1/6 y cubed minus 1/2 y. We can add c. Let's simplify this, and of course we have to go back to the original variable, which was x. So this is equal to 1/2 y to the fourth times inverse tangent of y minus 1/2 inverse tangent of y minus 1 over 6 y to the third, and then plus 1/2 y plus c. And let's go back to the original variable x. Remember, our integral was the integral of x times inverse tangent of square root of x with the substitution y equals to square root of x. Our final answer looks like this. Y to the fourth is x squared. So we have 1/2 x squared times inverse tangent of y, which is square root of x, minus 1/2 inverse tangent of square root of x, minus 1/6, and that's square root of x cubed. That would be x to the 3/2 power, plus 1/2 square root of x plus c. For more videos,